This is Geometry, Unit 5, Lesson 5 on triangle inequalities. What we're going to look at is some inequalities that exist when you're dealing with the sides of a triangle. So, our first postulate that we have is the shortest distance between 2 points is a straight line. So, if I want to go from A to B, the shortest distance between the points would go directly from A to B, rather than going from A to C to B. So, that means that if I take the distance A plus B added together, this plus this, I am going to have a value that is greater than what the distance from A to B is going to be greater than C. Now that will be true for the three sides of the triangle. If I were looking at B plus C, that would have to be greater than this plus this, than having going straight from B to C, which would be A. And if I said C plus A, that would be greater than B. So if I take two sides here, it would have to be greater than the third side. That is the triangle inequality theorem. In a triangle, the sum of any two sides of a triangle must be greater than the third side. So in order to make a triangle, that makes sense when you think about it. If you were trying to make a triangle, you would have to have the two pointy sides be greater than the third side, otherwise it would be just a straight line. So, if the sum of any two sides of a triangle must be greater than the third side, which of the following could be sides of a triangle? Well, let's see, we have 2, 3, and 7. Now, when you're using the triangle inequality theorem, it has to work for all the sides of a triangle. If even one pair of sides doesn't work, then this will not be a triangle. So, if I take my first two sides, 2 plus 3, they should be greater than 7. Is that true? Is 5 greater than 7? No, that's false. So, since that doesn't work, this is not a triangle, so this one is no. Now, even if you did the other two sides, if you did 7 plus 2 is greater than 3, or you did 7 plus 3 is greater than 2, these two work. But this one does not. So, if even one pair of sides doesn't work, then this will not work. Let's try this one. Let's try the different combinations. 6 plus 8 would have to be greater than 10. Well, let's see. That's 14 is greater than 10. That's true. If I took the other two sides, 8 plus 10, they would have to be greater than the third side, 6. Is that true? 18 is greater than 6. Yep, that's true. And then my other combination is 6 and 10 is greater than 8. 16 is greater than 8. That's true. All of the combinations of two sides that I did are greater than the third side. So yes, this is a triangle. The sum of two sides is greater than the third side. All right, let's try 6, 6, and 1. We have 6 plus 6 is greater than 1. That's true. 12 is greater than 1. We have 6 plus 1 is greater than 6, which is 7 is greater than 6. And then we have 1 plus 6, which is the other pair of sides. 7 is greater than 6. That works for all three of them. So this one is also yes. All right, last one. We have 4 plus 8 is greater than 4. That's true. 12 is greater than 4. Then we have 4 plus 4 is greater than 8. Now, is this true? Is 8 greater than 8? No, that's actually not true. If it's equal to, that doesn't count. It has to be greater than. So this one is no. This is not a triangle because the sum of two sides is not greater than the third side. It can't be equal to it. It has to be greater than. Now, of those triangles that we just figured out, which were the two above, which one of these could be sides of an isosceles triangle? Well, we decided that these two were triangles. Which one of 6, 8, and 10 or 6, 6, and 1 is isosceles? Well, it'd have to be 6, 6, and 1 because an isosceles triangle has two sides congruent. So it has two sides that measure 6. So it has two sides congruent. Now, which could be the sides of a right triangle? That's actually the other one, this one right here, 6, 8, 10. Now, how can we figure that out quickly if it works or not? Well, a right triangle, the Pythagorean theorem will work on it. So if I use the Pythagorean theorem and apply this, Remember, the Pythagorean Theorem says a squared plus b squared equals c squared on there, and the c squared is the hypotenuse. So if I have 6, 8, and 10, which one would be the hypotenuse? The hypotenuse would be the longest side, so that's the hypotenuse. So if I set up my formula, 6 squared plus 8 squared equals 10 squared, 36 plus 64 equals 100. Add these together, it works. The Pythagorean theorem works, so this triangle is a right triangle. Now the next thing we want to look at is the bounds on the third side of a triangle. We know that in a triangle, the sum of any two sides must be greater than the third side. So what we want to figure out is what are the values that could work to be a third side if we're given two sides. So, two sides of a triangle measure 4 and 7. So I've got a picture of that over here. What are all the possible lengths for the third side, C? Now, let's suppose that C is the longest side. Then if C is the longest side, the sum of these two must be greater than the third side. So that means 4 plus 7 would have to be greater than C. All right, combine your terms here. 4 plus 7 is 11, is greater than C. So if 11 is greater than C, that means that C has got to be less than 11. Now, if 7 is the longest side, all right, so that means these two added together have to be greater than 7. So let's see. 4 plus C has to be greater than 7. The sum of two sides has to be greater than the third side. Solve this for C. Subtract the 4, and that gives me C is greater than 3. So my values of C have to be greater than 3, but less than 11. Now, we usually write that as a single compound inequality. C in the middle. C has got to be less than 11 and greater than 3. So the values of C fall between 3 and 11. So my C value here could be 6. It could be 7. It could be 5. It could be 2. Any value that I plug in here, any sum of any two sides will be greater than the third side. So the values of C would have to fall between 3 and 11. Now we can actually derive a formula for this to figure out the values of the length of the sides. If we know the length of two sides of a triangle A and B, where A is greater than B or equal to B, then the length of the third side C must be, the formula is subtract the A and B, add the A and B, and then the C goes in the middle. So C is greater than A minus B, but less than A plus B. So if we use this formula, we can figure out each of the bounds of each side. So it's the difference between the sides we know and the sum of the sides we know, and C will fall between them. All right, so two sides of a triangle measure 6 and 13. How long could the third side be? So I'm going to sketch myself a triangle here. Here's my triangle. I don't know how long they are. Notice this isn't to scale. So this side is going to be 6, this side is going to be 13. All right, so this is going to be my C. That's what I'm looking for. How long can the third side be? Well, remember, the A value would be the bigger value. So this would be A. This would be B. So following our formula here, A minus B would be 13 minus 6. And then A plus B would be 13 plus 6. So the values of C, the third side, would have to fall between 7 and 19. So C could be any value between 7 and 19. So if I wanted this to be an isosceles triangle using these dimensions, what would the third side have to be? Would it be 6 or would it be 13? Well, because an isosceles triangle has two sides, it either has to be 6 or 13. If our C has to fall between 7 and 19, would it have to be 6 or would it have to be 13? It would have to be 13, because 13 falls between 7 and 19, and that will give me two sides congruent. So if the third side is 13, this would be an isosceles triangle. 6 doesn't work because it's too small. All right, let's try this with variables. It works the same way. The sides of a triangle measure x, 2x, and 5x minus 12. What are all the possible values for x? Okay, so when we work this out, we want to start with the longest side. The longest side between x, 2x, and 5x minus 12 is probably going to be this one. All right, so that's going to be my C. And then between x and 2x, this would be my A. and this would be my b. So if we want to set this up as a minus b between c and a plus b, let's get our values. Now be careful of your subtraction. So a minus b will be 2x minus x. And then this one will be 2x plus x. So that gives me x is less than, c is 5x minus 12, and 3x. Now remember, this is a compound inequality. There are actually two inequalities here. We have one that looks like this, x is less than 5x minus 12, and we also have 5x minus 12 is less than 3x. So I'm taking this half and then this half and solving each one for x. Now solving this for x, I'm going to minus the 5x. Negative 4x is less than negative 12. Divide by negative 4. And we end up with x is, don't remember, we divided by a negative with an inequality. The inequality is going to flip. X is greater than 3. And then this one, I'm going to add the 12. 5x is less than 3x plus 12, minus the 3x. 2x is less than 12, divide by 2, and we get x is less than 6. So that means that x falls between, x is greater than 3, but less than 6. So the values of x fall between 3 and 6. Okay, we can also look at the sides and angles of a triangle and do comparisons between them. On the triangle shown, what is the largest and smallest angle of this triangle? Well, just by looking at this, this would be the largest angle, and this is the smallest angle. Just by looking at it, we can figure that out. Now, what is the longest and shortest side of this triangle? Well, the shortest side would be over here, and the longest would be over here. Now, where do the angles and sides fall that relate to each other? The largest angle, largest side. Smallest angle, smallest side. Notice that they are across from each other. The longest side of a triangle is opposite the largest angle of the triangle, or across from. And the shortest side of a triangle is opposite the smallest side, or smallest angle of the triangle. So remember, in this case, opposite means across from. So if you want to know what the biggest angle is, find the longest side and go across from it. If you want to know what the smallest angle is, find the shortest side and go across from it. And it's a very handy way to do it. So if I know the sides of a triangle, I can immediately tell you what the biggest or smallest angle is. So if I have my triangle SML here, where sides ML is 6, SL is 7, and SM is 8, what is the largest angle of the triangle? Well, the largest angle would be across from the biggest side. The largest side here is 8, that is MS. So the largest angle is going to be angle L. What's the smallest angle? The smallest angle would be across from the shortest side. Well, 6 is the shortest side, so the smallest angle will be angle S. And it works in reverse. If I have my triangle here PQR, what is the longest side of triangle PQR? Well, I don't have any side lengths here, but I need angle measures. So let's see if we can figure this out. Let's figure out our angle measures. Now, remember, this is 125. This is an exterior angle. What do we know about exterior angles? Well, we know two things. They are supplementary to the adjacent angle, so these two right here are supplementary. So if this one's 125, that makes this angle 55. And we know that it's also equal to the sum of the non-adjacent. So if this one's 60 and this is 125, that means this one's 65, because 60 plus 65 is 125. So which one is the longest side of PQR? The longest side is opposite the biggest angle. This is the biggest angle, so PQ is the longest side. And the shortest side would be opposite the smallest angle, which would be 55. And so PR would be the longest side. So we have lots of theorems here based on finding the lengths of the sides of the triangle using longest and shortest sides and figuring out the angle measures